I wanted to take a look at a couple of problems dealing with the whole issue of independent versus dependent, and also finding the probability of independent or dependent compound events. So here we go with the first one. A bag contains some red colored and some blue colored marbles. First, a red colored marble is drawn, and then without replacing the first marble. So the big thing here is we did not replace the first marble. A blue colored marble is drawn. Are the two events independent or dependent or independent? Okay, in this case, it's very important that the first marble was not replaced. If the second event has a different probability than the first event, then they are dependent. So we don't know the overall numbers, but what we do know that when we pull that first marble and we don't put it back, you not only shrink down the total pool of marbles, but you shrink down one of the colors, whichever one you picked. You change that probability as well. So in this case, this is a dependent event because you don't put the marble back. If you had put the marble back, you would have been good, but you didn't. So unfortunately, it's dependent. How about the next one? What's the probability of rolling an even number on the first roll of a number cube and rolling an odd number on the second roll? Okay, so again, if we think about this, you have to determine if the probability of the second event is affected by the first. So the probability of rolling an even number on a number cube. Okay, so our numbers on a number cube, 1, 2, 3, 4, 5, 6. We want an even number first. So our even numbers are 2, 4, 6. So for the first roll, our probability is 3 out of 6. Now for the second roll, we want an odd number on the second one. So on the second, we want an odd number. Our numbers are 1, 3, 5. Well, again, that's also 3 out of 6. And you also have to think of it this way. When you roll a die, the die doesn't care what the previous result was. The die is just going to roll. It doesn't say, oh, well, the previous one was odd, so I better go to even. That's not how a die works. It doesn't have a brain. It doesn't think like that. So the first roll has no effect whatsoever on the second one. Their probabilities are the same. Therefore, this one is an independent event. Next one, suppose a number cube is rolled twice. What's the probability that an odd number will show both times? Well, we've already discussed here, when we roll a number cube, our possibilities are 1, 2, 3, 4, 5, and 6. If we want to roll an odd number, 1, 3, and 5, the probability when we look at compound events like this is we always have to multiply the probability of each event happening separately. So the probability of the first roll being odd is 3 out of 6. And then we multiply that by the probability of the second roll being odd, which is also 3 out of 6. When you multiply those, 3 times 3 is 9, straight across the top, straight across the bottom is 36. Now I see that 9 over 36 does not show up over here, so I have to simplify 9 over 36. I can divide a 9 out of the top and a 9 out of the bottom, and that gets me my official answer of 1 out of 4. So whenever I ask you the probability of two events, just take the probability of each event happening separately and multiply them together. How about the next one? A marble bag contains 3 red marbles, 4 gray marbles, 6 white marbles, and 5 black marbles. What's the probability of randomly drawing a red marble and then a gray marble if the first marble is replaced? Okay, so we got to find the probability of, first of all, reaching in there and pulling out a red marble. There are 3 red marbles overall, so this is the first pick. 3 red marbles overall out of a total of 3 plus 4 is 7, plus 6 is 13, plus 5 is 18. So the probability of my first pick is 3 out of 18. Well, how about the second pick? For the second one, I want the second one to be gray. Remember, we put the first marble back. So when we put that back, there's still 4 gray marbles, and there's also still 18 overall. Well, what do we do with those two things? We multiply them. So we multiply straight across the top. That gets me 12. I multiply straight across the bottom. 18 times 18 is 324. And I'm sure we can simplify that, but I'm not going to worry about it. And our final question, a coin is tossed and a number cube is rolled. Find the probability of a heads and a 7. Okay, so probability of flipping heads on a coin is 1 out of 2. No problem there. Probability of rolling a 7 on a number cube, well, heck, that's an issue. It is not possible to roll a 7 on a number cube. So we take 1/2 times 0, and that just gets us 0. So my answer here is 0. Use this video to hopefully help you go through the example problems next.